is Mr. Smith here. This is Algebra 2, Section 7.3. Using functions involving e. Oh no, right? So, as we've talked briefly before, e is simply a number. Right? This is a number between 2 and 3. It's 2.718, blah, 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 blah. It is irrational, so it has no end. So it's like pi, except it's smaller than pi. Okay? E is called the natural base. Okay? The reason we refer to this as the natural base is because, because it comes out in nature. Right? We see this in biology. The idea is when things compound, like compound interest, well, a bank chooses an arbitrary compounding period, quarterly, monthly, yearly. That's an arbitrary man-made thing. Biology doesn't wait to compound based on man-made ideas, right? If two cells are going to divide, they don't say, "Ooh, we got to wait another 10 minutes before we're allowed to divide." Right? Cells divide on their own time, and so we consider this as a compound continuously idea. All right? And so when we compound continuously, we need the number e, called the natural base. It's named E after its founder, Leonard Euler. Starts with an E, though. Okay, so all of our rules still apply. E is just a number. Don't discriminate. Don't be freaked out. It's just a number. So if I have e squared times e to the fifth, well, the rule says we add the exponents, so this is e to the seventh. If we're dividing, the rule says we subtract. So 12 divided by 3 is 4. E to the fourth divided by, e to the fourth minus 3 is just e to the first, or you can just put it 4e. Okay, here in part C we get a little bit more complicated, but still the rule says I bring the 2 in to both pieces. It gives us 5 squared. And then e to the negative 3x squared, which will be e to the negative 6x. All the rules for exponents still apply. E is just a number. Your calculator knows what e is. So everyone should at this time take a moment to look at your calculator, and almost all of them will have a button on the front that says e to some power. It says e to the x, usually. Okay? The reason is because almost 95% of the time we want to take e to some power. But if you take e to the first power on your calculator, if you just go e to the power of 1, it'll give you this number back, 2.718. Okay, so there should be a button on the calculator. If you can't find it, see me later, that says e to the power, e to the x. Okay. Of course, we can create an exponential growth function with e. We can create an exponential decay function with e. Okay. Here, if we graph y equals e to the x, this gives us exponential growth. Here, if we graph y equals e to the negative x, that gives us exponential decay. Remember, in all of this, e is simply a number. Bigger than 2, smaller than 3. In this section, they emphasize graphing a little bit. I'm going to gloss over that. I'm not going to emphasize the graphing component as much. I more want you to be able to work with the number. Just want you to be able to work with the number. Your graphing calculator will graph these. So let's take a look here at part A. So here we're going to graph y equals 2 times e to the 0.6x power. Okay. So for this problem, I'm not even going to start with an xy table because we can't do it really by hand. I'm not going to ask you probably to graph this by hand. Let's just go right to the graphing calculator. And here you are. Exponential growth. Everyone should try this. If you're watching the video at home, please try this. Y equals 2e to the 0.6x. Make sure that you are using the correct E button. You can't just type the letter E. You must use the special button. Otherwise, it won't know what you're referring to. Okay. And then this is just a standard zoom, zoom 6, zoom 5 on the Inspires. Okay. We can talk about domain and range here. The domain is all real numbers. I can plug in any x value. The range values are going to be from 0, not including 0, all the way up to infinity. 0 to infinity. Okay? This would be the extent of your graphing. I won't ask you to do anything more with graphing. But I will probably show you an applied problem or two where I want to do something that's continuously compounded. Continuously compounded. So if I tell you whatever's occurring and it's being compounded continuously, then this is the formula that you're going to need. You need to memorize this. The top one we've seen before. So P is your principal, E is our number, R is our rate, and T is our time. A is the ending amount. A is the ending amount. All right. So when we look at this problem, right, we're talking about compounded continuously. So this tells you what formula you're going to use. I have to tell you that. I'll either say it's compounded quarterly, compounded continuously. When I tell you that, that's the cue. You're going to use this formula: A equals P to the A equals P times E to the RT. Here are the principals 4,000. Here are interest rates 0.06 times 2 years. And when I do this, we get a number like, what, $4,509.99? No. Yeah. Okay. Something of that nature. Okay. So this is what you'd be expected to do. There's one more problem in this section. It's the baby shark problem. Do. Right? So look at this baby shark, and they give us this equation right here. They ask us to graph that and use the graph to estimate how long the shark is after 3 years old. Now, one thing that we could do is we could just plug 3 in. We could just plug 3 in, and that would tell us how long the shark is. And by the way, this is going to be in centimeters, just so we know. All right, so it would tell us how long in centimeters the shark is. But since they ask us to graph it, we'll go ahead and take a look at the graph. And the equation is L equals 337 minus 276e to the negative 0.178 t power. Okay, and we can plug that right into our graphing calculator. So we come over to graphing calculator, and let's go with a new page for here. And 337 is 276 e to the negative 0.178 t. And of course, we don't see anything because that would be too easy. And I should put an X. Thank you. And now I see something, but it's not really useful. So let's go menu, window zoom, zoom out. Let's see if we can. Oh, there we go. That's kind of interesting. And remember, I only want an x value of 3, so maybe the best thing to do is to change this by hand a little and just change our x max to 10 and our y max to -5. Okay, so now I can see this graph. And if we go menu, trace, graph trace, at 3 years, I can see down here that the shark is 175 centimeters long. Okay. Again, if I plug in 3 in for x, I'll also get back 175. Now again, this takes a little bit of time to adjust the window settings. I would urge my students to spend some time working on their calculators, figuring out how to get this so it looks nice. Okay. All right, so this concludes Section 7.3, the introduction of the number E. Thanks for your attention. Have a good day.